Hi everyone. In the second example, we will solve the Monte Carlo methods, estimating pi value. Okay. Firstly, we need to define the 10,000th of the number of random points. Okay. After that, we need to generate random points in the unit circle. Okay. Which means that we have 0 1 times 0 1. Okay. X is equals to what? To rent n1, y rent n1. Okay. So after that, determine if points are inside the quarter circle, which is equals to the what? The inside x dot 2 plus y dot 2 smaller than equals to the 1. Okay. This is our guess. So estimating pi value, pi estimate is equals to what? 4 times sum of inside value divided by n. Okay. After that, we can draw the whole of these terms in here. The scatter can be used in here, x inside and y inside 1 and blue. Okay. And scatter, it's the same condition, but in this case not inside. Inside, not inside. Okay. So this is the red one. The theta line space can be defined with the 0, pi divided by 2, 90 degrees, 100 points. Okay. And also plot cos theta, sin theta here, and k, and line white 2. This is the representation of the what? The quarter circle region. Okay. So first of all, the title as printf can be used in order to what? In order to write the figure text Monte Carlo estimation of pi estimated pi is equal to percentage dot 5f. Okay. So pi estimate can be given just like this one, and x label is x, y label is y, and axis equal must be given in here, and hold off should be given in here. Okay. So pi estimate can be seen on this page, but we don't need to do that. If you run this code, just see that the estimated pi value is 3.15, but if I increase to what? 100,000th value, and so 3.1417, so it's closing to what? The real pi value. But if I increase the values of the n, see 3.1402, right? Or increase the 10 point in here. See, it's closing to the what? It's closing to the 3.1425, and one more 0 is added in here. It take maybe long time, but we can wait. There are too much points in the figure 1, and so 3.1419. It's closing to what? 3.1416 values. Okay? So these are to what the Monte Carlo methods to estimating the pi value in this case. Okay? Another important example is given by with the what, with the importance sampling example. Okay, so n can be built with the 10,000. This is the number of samples. Okay, and lambda is equals to the 1, and so exponential, this is the rates of exponential distribution. These are to what the basis to what to calculate the probability of rate of these terms. Okay, and so we need to generate samples from the exponential distribution truncated, for example, at x2. Okay, u is the round and 1, and u truncated is equals to the u times exponential minus 2. Okay, and after that the inverse mapping should be given in here, minus log u truncated. Okay. We should scale the whole values in here, and also the x is applied to the what to inverse transform sampling. Okay, after that just remember the R formula, the compute weights manually in here, the px value is the truncated standard normal distribution, just like this one. Px is equals to the phi x divided by 1 minus phi 2. Okay, and for x greater than 2. Okay. Also we need to give the qx value our basis exponential distribution, but truncated values of it. Qx is equals to the lambda times exponential minus lambda times x divided by exponential minus 2. Okay, and so this is for x greater than 2. Okay. After that we need to compute phi x, just like this one. Phi x is equals to the what, the 1 divided by sqrt 2 times pi, okay, times exponential term minus 0.5 times x dot over 2. Okay, these are the formulation. So in the second case, compute phi 2 value. This is the standard normal CDF at x equals 2. This is the standard normal PDF. Okay, this difference, and so phi 2 is equals to the what, 0.5 times 1 plus error function 2 divided by sqrt 2. Okay, and so this is the approximation value of phi 2. Okay, and after that we will have to the what, do compute px. Px phi x divided by minus phi 2, and also qx lambda times exponential minus a lambda times x divided by x minus over 2. Okay, so how can we compute the weights in here? Weights is equals to the what? Px dot divided by qx, and estimated EP value over x square, and so EPx2 summation of x dot over 2 dot star weights divided by some weights. Okay, these are the formula, and after that we can write it. For example, if I run this code, and then we will have the 5.74 value in the approximation of the what our integration value. Okay, this is just simple is that we just use this information, and then we can rewrite everything based on this information, just like this one. Okay.